Hi everyone, welcome to our YouTube channel. I'm Angel and my friend is Faris.
Hi, Faris.
Oh yeah, okay. Actually we want to say thank you to our respected lecturer, Dr. Naufal. And today we are going to show you how to do the AM modulation. So let us start. Basically, we are using SIMULINK, as you can see. We are using Simulink and the Simulink library. And at first we can see from the sign carrier, we use the sign modulation. Yeah. Also, we can use signal generator. Yeah, you can find it in the Simulink library. Okay, for the properties, we set the value for our amplitude is 2, and for our frequency we use 2 pi 1 because we want the value to be 1 hertz. So you can apply it and okay. Yeah. And then for the modulating signal, we use the amplitude for 1 and then the frequency 2 pi 20 or 20 hertz. If you are using signal, what is it, Paris? Signal generator, right?
Signal generator, yeah.
Yeah, if you use signal generator, is much more easier actually because you can just put the hertz what you want, maybe 20 hertz. Yeah, you don't need to use pi.
Here's a signal generator.
Yeah, we can see the examples here. Yeah, this is the unit. See, we can have the units here. Okay. But this time we choose sign generator, sign
Yeah,
signal.
correct. Yeah.
Okay, and then as you can see, we put also the product or the sum. The sum is, you can get it from maths operation, right?
Yeah. Or you can just type at the search bar here, type sum.
Yeah.
Also works. Then you can just take here.
For sum.
Yeah.
That is for the sum sim. We want, if you want to sum the carrier and the modulator signal. Okay. And then we go to the scope. Is actually for us to see the, like the scale and the wave. So, and then for the modulation index, yeah, we can get it from maths operation too.
Mm-hmm.
Wait, no, yeah, it's from scopes. No, it's from.
Well, basically, you can, for any of these components here, you can just open the library browser here. And then
Yeah.
over here are all the things that you can use lah. Most of the time, you'll be using things from the, well, not to say communication toolbox, but you can just type here like the things that you need. Of course, to produce a AM signal, you need a sine. Yeah. So you need to take a sine wave over here. This is how I got the sine carrier and the modulating signal. And for the product, you can just type in product. This will basically like this product here. The product here is used here, as you can see, and here to combine the modulating signal and the carrier signal.
Okay. And then we can change the value, constant value to 0.5 for our modulation index.
Oh yeah, the constant. Yeah.
Constant.
To actually have a constant like this 0.5 and over here 1, you can just type in the library browser, type constant, and you press enter. And you just drag one of the variables here, and over here, you double click it. You can just change whatever value you want. Yeah, something like that.
Yeah, if you want to find it, you also can find it in sources.
Correct.
Yeah. Okay, after that, we move on to we want to run the simulation right now, right?
All right. Yeah, sure. Let's do that.
All right, let us see our wave. What is the result?
All right. Mind you, it's taking a while to run the simulation. I have a slow computer.
Yeah.
All right. Okay, so basically, if it shows here at T, it means it's running already. Now, as mentioned before by Angel, you can analyze each part of the signal based on the scope over here. Now, there's scope 2. Scope 2 is analyzing the modulating signal. See, as you can tell here, the scope 2 is connected here after the summation. And then scope here is analyzing the signal after combining both the modulating signal and the carrier signal. And then the scope 1, last but not least, basically analyzes the signal coming out from the carrier. So I'll analyze the carrier signal. So yeah, this is your carrier signal.
Yeah.
The amplitude here is set to 2. As mentioned by Angel earlier, we set the amplitude by 2.
Yes.
And from here, you can actually calculate the period, and you should get the same frequency as what we keyed in earlier lah. So this is the carrier. Very straight. So nice. Okay.
So nice signal.
Yeah. Now let's move on to the modulating signal here. I'll open scope 2 now. Voila. Where?
Wow.
I'll drag down a bit. Yeah.
Yeah.
Frequency is quite high for the modulating signal. We set it quite.
Drag a bit. Drag down a bit.
Yeah. Wait, let me get rid of this marker here.
Yeah. Okay, how we get rid the unwanted circle? Let us show you. You
can go to view.
Okay.
Style. And then over here, marker. Basically, the marker tries to mark the critical points of the signal, but in this case, you don't need to, because we just want to see if we can produce a AM signal. So we just press none and apply lah. Now, okay, this is our modulating signal. Now we set the frequency to be quite high, so that's why you can see that it's generating so fast, and the period is very small. Now, yeah, I'll prove to you. I'll show the circuit here. The modulating signal. See, it will put 20 hertz. And then earlier the sine carrier, right, was so slow because we put 1 hertz. So that's why it was slow. But then we put 20 hertz, so it was like faster than the sine carrier lah.
Or maybe do you want to show them how is it if we make it slower?
Sure. All right. So I'm just gonna press X here and stop the simulation for a bit. All right. Yeah. Again, it's a slow computer.
Yes.
All right. Okay, so just now was 20 hertz. So I'm just gonna set to 1 lah, 2 lah. I'll set 2 lah. Okay, so 2 hertz. So it should be slow. Because as you know, right, the producing a sine wave, to manipulate the frequency of the sine signal produced is by manipulating omega, which is part of the sine function. So it's actually like sine omega t. So when omega is usually equals to 2 multiplied by pi multiplied by the frequency. Now, basically, you can manipulate that lah. That's why we use 2 times pi and frequency. Basically, this frequency represents omega lah, and 2 times pi times the frequency. Now I'm changing it as you saw earlier. I changed to 2. Now I open back the signal. It is much slower. It's much slower than earlier. Earlier was faster.
Yeah, true.
All right, so That's the fun part. You can change. And of course, this is the modulation index. Doesn't matter really. You can just change it because as long as you multiply with the coefficient of the sine function. All right. Now let's see the product of these two, the proper AM waveform that we actually want to see. So when you combine both the sine carrier and the modulating carrier, you should produce an envelope. But where? Yeah, so this is basically it. I'll produce a better one because right now the frequency is too slow.
Yeah, we changed again
Yeah, okay.
the original signal.
Yes. I'll choose one lah, modulating signal 1. And then carrier I change to 10.
I think isn't it the modulating 20 just now?
Oh yeah. Sorry, again.
20.
Right.
That is 1. Okay.
Now I'm gonna run. So we can, like I said again, we can analyze the produced waveform using the scope. You can get the scope from the library browser, and if you double click the scope, you can see the signal.
What a nice signal you got.
Thank you. And let me see a closer look. Yeah, this is the signal produced lah, basically. It's just kind of nice.
Yeah.
All right.
Yeah. So that's it, right?
That's it. Yeah.
So that's it for today. So stay tuned to our YouTube channel.
Oh, stay tuned. Right.
Bye.
Okay. Bye bye.
Thank you for watching.